Alright, so in this video we're going to be talking about nodes and a little bit of theory about them and also how we would represent them in code. So let's go ahead and start by just laying a quick groundwork for how we would represent some nodes when we're drawing this out. So here I've got a node list. So each of these boxes you see here, it represents one node. So you can see we've got 5 of them, and you can see that there's 2 parts to each node here. Okay, you can see we have 2 boxes to represent that. So what these 2 spaces represent are the 2 fields that are going to be present on a node. It's going to be the data and the next pointer. So for example, we can just go ahead and make this easy on ourselves by labeling these nodes. And so we're going to have their data be just a letter. So it'll be A, B, C, D, and E. Okay, and then we'll refer to these nodes as node A, B, C, D, and E from now on. Okay, and then the other thing that each of these nodes has is the next pointer, which just tells you how to get from one node to the next node in the list, because that is how a node list works. It's kind of like a trail of breadcrumbs. So each node will tell you how to get to the next one, and so you just follow that link to go to the next. So that's why this second space here is going to be filled in with an arrow, and so this represents the next field pointing to this node right here. So in a standard node list, you'll just have something like this. Okay, and then right here. So notice that the next field or next space of this E node is empty because that is the last element in our node list, and so it will not have a next field. Okay, and that makes sense because there's nothing after it. So let's go ahead and see how we can represent these in code. So I have here an empty REPL. So all I've done here is create the file node.java, and so this will hold our node class. Okay, so with this, all we're going to do is we're going to say public class node, because that's what we want our class to be called. And in here, we're going to have 2 variables. So the first is a public string data. So your data could be really any data type, but for the purposes of this example, we'll just keep it as a string. And then your second field is going to be a node type, and it's going to be called next. And the reason it's a node type is because if you look back here, our next field points to a new node. Okay, so just remember, this is just pointing to the next node in the list. Okay, so that's why we have a node data type. So this is the node class. Now here in main, let's start out by doing probably a pretty simple example. Let's just try and get the node at a given index. Okay, so what does that mean? You can see here these have some arbitrary data, but if we were to think about this in terms of a traditional array, you can think of this as the 0th element, 1, 2, 3, 4, 5, so on, so forth. So let's say we wanted to get the element at index 2. Okay, so that means we want to get the element here with that says C. Okay, and when I say element, that just means some element in this node list. Okay, what do we need to do that? So anytime we have a node list, all we get is what's known as the header node, and that's simply the first node in your list. So in our example, that's this node right here. So this node is going to be the header. Okay. Now, when we get the header node, we're able to access the entire list because we can just keep going down the arrow. We can always follow the arrows. So we can go to this node, then follow this arrow to go to this node, so on, all the way down the list. Okay, so if we want to get the index element 2, then all we need to do is we need to somehow, so we're past our header, and then all we need to do is we need to go down our list, and we need to keep track of how many nodes we visited, and that should get us to where we want to go. Now, the one thing to keep in mind is if somebody, if we have an out of bounds issue where if somebody, for example, in this node list tries to get index number 7, obviously we don't have any index greater than 4, so we need some way to catch that and stop it. Okay, at least stop it from giving us an error. So in this case, we'll just return null if that's the case, if they request a node outside the length of this node list. So we'll go in here. So we're going to create our method. So it's going to be public static string get string, because we're not going to return the whole node. We'll just return the data in that node. So in this case, if we're testing this with index 2, then we want to receive back the string C. Okay, now it's going to take a node header. Obviously, we want to get our first header, and it's going to take an integer index. And so that'll just tell us where we want to stop or which element we want to get. Okay, So now inside of this method, we'll start by defining a node variable that's going to be called current. And the idea is that current is going to keep track of which node we are, currently visiting. And so the idea is that we just walk down our node list. So we start here, then we go down here, and we go down here. And each time we go down, we're just going to keep track of our count. And then after we've hit our count, our current will be pointing to the element that we want. So to do that, we're going to then create a for loop. Now we're going to go from I equals 0 all the way till I less than index, and I'll explain why it's not index plus 1 or minus 1 in a bit. Okay. Now, one thing we need to keep in mind is that we want to have this, overflow or this out of bounds protection. So we're going to have an if statement to check for that. If the current.next equals null, so that means, let's say we've reached index 4. Okay. Current.next is going to be null because there's nothing after it. So in that case, we're just going to go ahead and return null. Okay, we're not going to do anything special with errors. Okay, now this next line is responsible for walking us down to the next element. So current equals current.next. We are moving current down one element in our list. Okay, now the final thing we just need to do is return current.data. So after this loop is finished, current is going to be pointing to the thing we wanted to point to, and so we will be ready to test this out. Okay, now the reason we are going up to I less than index, so let's go ahead and take a look at the example of index 2. Okay, so if we do I less than 2, we are going to have for our values of I 0 and 1, and we're going to stop there. Now the reason that it's not an issue is because when we do this for loop, we say current equals current.next. So when we are at index I equals 1, we're going to be pointing right here, and then we say current equals current.next, and so that'll take us to index 2, even though I never does equal 2. All right, so now we can go ahead and test this. Let's check the error. That should be fine. So the way we'll test this is we're going to create this node set in our code. So what we'll do is we'll start by saying node h equals new node, and we'll say h.data equals a, and we'll say h.next equals new node. Okay. Now here, what we need to do is we'll say h.next, data equals b, and then h.next equals new node. Now the reason I'm not creating more variables to store these is just to show the point of why we actually need to use methods like these to access a certain element in our node list. Okay, because we can't just type h.next a bunch of times. So now that we set this as a new node, we can say h.next data equals c, and actually, so we'll just go h.next next. So it gets pretty tedious after a while, so I'm going to copy paste, and every time all we do is add a .next. Okay, and this will be d, and so the final one. All right, so notice I'm not going to set the next value for this one because we do not want e to point to anything. Okay, so now what we can do is we can come in here, we can do system.out.println, and we're going to print out the result of getting, and we're going to pass in h, and our index like we wanted was 2. So we should get 0, 1, 2. We should get c printed out. We can run this. And you can see right here, we get the letter C printed out. Okay, so that is how we would do the get method to get a specific element at a given index. Now, if we wanted to print out an entire node list, okay, how would we do that? So what we'd do is we would essentially just start at our header, and we would visit each element. So we would go to each node here, and we keep going until we hit the end of our node list. So that means when we don't have any next to go to, and we would simply print out whatever is in data at that current node. So let's go ahead and see how we do this in our code. Okay, so we're going to start with our method signature. So public static void print nodes. We don't need to return anything because it's just printing our nodes out. So we're obviously going to need to take the node header because that's what we're printing out. And so let's start. So our first thing that we need right off the bat is check if header is null. So header would be null if we had like theoretically an empty node list. So if header is null, we just want to print the word null. So that's what we're doing here. If header is equal to null, we just print out the word null. Now, the approach we're going to take to this is we're going to create a string called RV, and we're going to keep appending our data to RV. So we're just going to append the data at each node and some small like arrow symbol, and then we'll keep doing that. And at the end, we'll print out this value. Okay. So next, what we'll do is we are going to create our current node variable. So what this will do is this is going to act as our index or our tracker, and this is just going to go down each of the elements in our node list, and we'll be able to access the data for each of those. Okay. Our next bit is this while loop. So we're going to go while current is not equal to null. So when would current equal null? When we don't have any element, when we've reached the end of our node list. So that's where we're going to go up to current is not equal to null. Now, there's another way to do this with current.next not equal to null, but both methods work equally fine. Okay, so we're going to do while current is not equal to null. So while current is not equal to null, we're going to append to this RV, that's what the plus equals does there, current.data, right? So if we just left it like this, we just get the string, for this node list, A, B, C, D, E. But, we want to make it a little bit nice. So we also want to add in a little arrow symbol. I'm just going to use the greater than symbol. Okay. Now the thing is, we do have to account for the last element of the array, or of the node list, sorry, where we want it to not just have an arrow pointing into nothing, but we want to have the word null there just to show that it's a null pointer. So if the current.next is equal to null, we are just going to append an arrow pointing to the word null, and we'll be done there because this will trip our while loop. Okay. Now, however, in most cases, this else statement is what will be running. And here we're just going to append an arrow with spaces on both sides for some nice format. Okay. And finally, we're going to move our current down one element on our node list by doing current equals current.next. Okay, so what this will do is if we were at A, then A.next would be this arrow pointing to B, so we'd be at B, then B.next is going to C, of course, and then all the way down. So now all that's left to do is print RV. So we do that right here, and we are now ready to test this out. So we can come in here into our main, and I will comment out this line right here for that test. And so now what I should be able to do is I'll do print nodes H like that. Okay, now what are we expecting? So I'll say expecting, and so we have these nodes here. So we'll say A going into B, going to C, going to D, going to E, and that goes into null. And now if we run this, that's hopefully what we get. And there we have it. So we have A, B, C, D, E going into null. So I'll just remove this hello world line. And now what we can do is we can make this like, we can make this whatever we want. So we can make this a smiley face. We should see it show up where C used to be. There we go. We got that, right? Now, make this back. If I commented out this last bit where we created a new node, then we could do this and it would just end at D. So we'd have D going into null. And so yeah, everything works out. All right, so now that we can print out our node list, let's go ahead and talk about how we would add something into our node list at a given index. Okay, so for example, let's say we wanted to add in an element at index 3. So what exactly does that mean? Let's talk about that first. What that means is we're going to add in a new element so that with all the new elements in place, the index of our new element will be 3. So let's just look at that visually and then hop into the code. Okay, so what that means is we pretty much want something to show up right here. Okay, we want some node to be right here in between these two, because after 2 will be this element 3. So then this will become 4 and this will become 5 after we add our new node. So let's talk. How can we achieve this? How can we make this possible? Okay, so the first thing that we want to do is, well, essentially we want to do this. So we want to here's the top level overview. We're going to create some new node here. Okay, we're going to have this link over here, and we're going to have this guy link over here. Okay, that is the essential idea of what we're doing. Okay, so that C will link to whatever our new one is, and whatever our new one will link over to D, and then this will become our new index 3. So let's talk about a little bit more specific details. So the first thing that we need to keep in mind is we need to have D, okay, or we need to first break this relation here. So I'm going to cross it out to show that we're going to break that, because now C is going to be pointing somewhere down here. Okay, so we're going to break this this relationship, this next relation, and we're going to create our new node. And for example, let's say our new node is going to have the text F. Okay, so you want F to show up right here. All right, now what we need to do is we need to have, actually let me just move this guy down here. Okay, so we want our new node with the text F. All right, cool. So what we want is for our next pointer of the element C to point down to F, like so. And then we want this next here to point up to D. Okay, so that makes this guy number 3, F, and then this will become 4. So now the new path, if you imagine it, is going to go like this. So go A to B to C, then down here to F, then up here to D and E. Okay, now the fact that F is down here has nothing, it has no effect. I just drew it like this to show easily where we're inserting it. Okay, so now one thing to keep in mind is we started out by breaking this link, but the moment we break this link, we have no way to get back to D. We have no way to reference D, and we know that we do have to reference D in order to have this node, this new node, point to it. And when I say D, I mean the element after. So, you know, what we ideally do is have some kind of storage variable that would store this while we create the new node and then have this node point there. Okay, now one other thing is, if we talk about how do we know where do we add in our new element, like how do we know where we have to break the link? Well, that's pretty simple. So if we wanted to add in an element at index 3, okay, that means we have to start by modifying the element at index 2, right? Because we have to get to 2, we have to figure out what 2's next is, we have to save that in a variable, in a storage variable, and then pull c.next to equal some new element. So we kind of have an idea that if we're trying to insert at index n, we want to get all the way up to index n-1 and then do this algorithm that I've described here. Okay, and I think this visual representation is a pretty nice way of imagining it. So let's erase that. Yeah, so we're breaking this original link and then we're creating a new path through here. Okay, so let's go ahead and talk about how we would do that. So we're going to start out with our method header. So we're going to have public static node add, and notice we're returning a node type because we're going to return the mutated or changed node list. Okay, now we're going to take a node header because that is going to give us the node list we're modifying. We're going to take a string s, which is going to be the data for the new node. So in this case, we want it to be f, and then we're going to take in the int n, or the index of where we want this to be added. And in this case, we're going to pass it in 3. So now the first thing we're going to do is we're going to have our current variable. You'll see this all the time with nodes because we do need some way to keep track of where we are down the list. Okay, now we're going to start with that current, and next we're going to have a for loop. Now here we see that n-1 I was talking about because we want to get current all the way up to n-1. And so this for loop is going to have just one line in it, current equals current.next. So we're just going to keep going till we hit n-1 and we stop there. Okay, so now current is pointing at n-1. We're going to start by saying node new next equals current.next. Now why is it called new next? Because it is going to be the next field of the new node we're adding. So I call it new next. You can also think of it as our storage variable. Okay, so now in this case, right, new next is going to be equal to D because current is going to be at index n-1, 3 minus 1 is 2, so we'll be right here at current. Current.next would be D, our node which has the data D. So now that we have that in our storage variable, we are free to go ahead and say current.next equals new node. So that is essentially breaking this tie right here and creating this new node that's down here. Okay, but then the new node won't have this data or this next arrow just yet. Okay, so next, we can go ahead and say current.next equals new next. So what does that mean? I know it gets a little bit confusing. So current So again, just visualize this is the best way to think about these. Current is pointing right here. Okay, current.next is our new element. That's pointing here. Current.next would be this arrow right here. And that is going to be the next field of our newly created element. And that is going to be equal to the storage variable so that we complete the chain and we don't drop everything after our insertion point. Okay, so current.next equals new next. And so try working this out on paper. Just make sure you can understand how the node list flows from one element to the next. And then we can say current.next.data equals s. So here we're just setting our data. In this case, it's going to be f when we write our test case. Okay, so it'll go set the data. And remember, current.next would be our new element because current is going to be n-1. Okay, don't get confused and think that current is pointing to the newly created element. It is not. Current.next points to the newly created element. Now finally, the last thing to do is return our header, h. Notice that I'm not returning current here. Okay, and the reason for that is that current is going to be pointing somewhere down here. It'll be pointing at index n-1. But header will always be pointing at index 0. And because everything here is passed by reference, by passing header, we will pass in the node list with all our changes updated. So let's go ahead and write a test case. This error should resolve by itself. Yeah, we're returning a node. Okay, so what we'll do is we'll start by printing nodes, and we can see what that gets us. So that should just give us A, B, C, D, E, and then null. That's what we have. Once again, real quick. Okay, so we got A, B, C, D, E, null. So that's our original node list, and so we can say to modify this, we'll say node x equals add, and we'll do h because that's our header. We're gonna have f as our data, and we have index 3. So now, if we go ahead and do print nodes x and run this, we should be expecting what we have right here, A, B, C, F, D, E. Let's make sure that's what we get, and that's exactly what we get, A, B, C, F, D, E, and then pointing it to null. So something to note is that this algorithm here actually will not work if we are inserting at index 0. So if we put index 0, we would expect to see F and then A, B, C, D, E, but that's actually not what we're going to get. So you can see that it messes up. It puts it at index 1 actually. And the reason for that is that because of the way we're handling our nodes with our header here being our actually having data in it and being an actual element of the list, we have to deal with any index 0 cases separately. So what we just want to do is we want to say say if n equals 0, then we want to do the following. So if n equals 0, we'll just say node new header equals new node. And so this is just going to be the new header, because if n is 0, then we're modifying the header. Okay, so we'll say new header dot data equals new, sorry, not new, it'll equal to s, because that's our data we're being passed. And then finally, we're going to say new header dot next equals h, which could be thought of as the old header. So when you say that new headers next is the old header, you're essentially taking the entire existing array and putting it after our new header here. Okay, and then we'll just return new header. Now, because we have the return statement, it'll never reach anything down here. Okay, and we can go ahead and run this now with f index 0, and we should see everything work as expected. And there we go. Okay, I've cleaned up our diagram here a little bit so that we can talk about removing a node. Okay, so to remove a node, we're going to follow a similar thought process as we did when we're adding a node. So we're just going to be thinking about linking and delinking things. Okay, so let's go ahead and say we wanted to remove element index 1. So that's this node B right over here. Okay, let's think about how we would do that. What we essentially want to do is take this link that goes to B, and I'm going to cross it out. I'll use yellow because we didn't use that. Okay, so I'm going to cross it out. So I'm going to delete this link, okay, because we don't want anything pointing to B. And then we're going to create a new link. So I'll make it in dashes to show that it's the new one. And we just want A to simply point all the way to C. like that. A.next should point straight to C. So we're leapfrogging B, and really we don't even need to delete this link. When we create the new one, it'll overwrite the old link automatically. So we can theoretically do this with some very short code. Okay, and we don't need to worry about doing anything with this link here because nothing ever gets to B. Okay, we don't even need to worry about that. Okay, and of course, like last time, if we are dealing with index 0, it's a special case. So in this case, all we would do is we would, since there's nothing before it, like notice when we're dealing with index 1, when we're trying to remove 1, we have to modify n minus 1 or 1 minus 1, which is 0. We have to do index 0.next. We have to modify that. But if we're trying to remove index 0, we can't exactly, we can't take anything at index -1. So instead, what we have to do is we have to make B our new header, and we'll look at that in the code. All right, so for the code here, we're just gonna hop over here. All right, so we're gonna start with our method header, public static node remove. Once again, we're returning a node type because we're gonna return the modified node list. Okay, we're not gonna modify it in place. So we're gonna take in a node h, and we're gonna take in the int index, which we're supposed to delete. All right. So here we're going to start with our current variable, which is just going to hold our placeholder. So we're going to go down the node list. And here we're going to say for int I equals 0. So we're going to go from 0 all the way to index -1. And we talked about why right here. Okay, we need to start at index -1. So I will go over the n equals or index equals 0 case at the end. So now all we're doing is we're going to say current equals current.next, and that's just going all the way down the node list until we reach our desired position, which is n or index -1. And here's the real line that does most of the work. So current.next equals current.next.next. So a lot of currents, lots of nexts in this line. So let's understand and break down what exactly it's doing. So current.next, well, let's say what is current? So if we pass in an index of n equals 1, for example, current is going to be at n-1, which is 0. So we're saying current.next, which in this case, since we're setting current.next equal to something, we're not actually modifying this object, but we're modifying this reference right here. So when we say current.next equals current.next.next, well, let's break this down. So current.next here is, well, we haven't deleted this yet, so it's going to be b, and b.next, because we're doing current.next.next, that is equal to c. So this line essentially says a.next equals c, and that totally removes b from the picture. And you can imagine the same thing if we had index 3, right? We would have 2, and so we'd say c.next equals e, and we're done. Okay, like that. And if we're at e, then it'll just be equal to a null. So now what we can do is we need to, well, first of all, we're going to return h. Okay, so there's that. And the final thing now is we need to deal with our, our index equals 0 case. So with this, all we're going to do is we're going to say if index equals 0, what we essentially want to do is we just want to say our new header is going to be equal to b. So we can literally return h.next. And so what that'll do is by returning h.next, we've essentially, for example, in this case, if we pass in index 0, it'll return h.next. So if we return b, then b becomes the new header. And if b is the new header, no, that's good. Okay, so if b is our new header, then there's no trace of a ever existing. So let's go ahead and test this one out real quick. So let's open up our main. I'm gonna comment out our test right here. So I'm gonna keep the print nodes h right there because I want to see our before and after. So let's start out by removing index 1. So we want to see a, c, d, e null. So we don't want to see b in there. So we're going to say node y equals, and I'm just using x, y, z. You can use whatever you want. So node y equals remove, and we're going to pass in h and an index of 1. So then we'll print y, and we run this. We can see we get A, B, C, D, A, C, D, E, null. So we have that B element missing here. Okay, and that's perfect. Now, if we do node Z equals remove H0, we want to see just B, C, D, E, null. If we do print nodes Z, run that, we get C, D, E, null, and so we can find out why that's happening. If we print what exactly we're modifying before. It should be obvious. So because we are actually passing this reference here, H is getting mutated. So if we just check this real quick. Yeah, so you can see here we are dealing with this ACDE null. So what I'll do is I will comment all this out. So now all we're doing is, and I'll comment this out. So now we're not, you know, modifying H twice. We're just going to modify it once, and we'll say print nodes H and then remove index 0. So we should see ABCDE null on the top line, and then this BCDE null because we removed our 0th element here. All right, and so that wraps up everything we got to do with nodes. So I hope this has been a helpful video.